Hello guys, my name is Muhirwa Emil. We make a research on pressure. I'm with Kelly Yamuhoza Muneza Ivan. As you see how we have made a research on a pressure as you see here. Here we have lower air pressure, high air pressure and sea level. What you should know about the pressure, see below. We have table content, definitions of pressure, calculations, types of pressure, absolute pressure, gauge pressure, differential pressure, difference between absolute and gauge pressure, sealed and vacuum pressure, cyclones and anticyclones, factors that influence pressure, importance of pressure in agriculture. Definitions of pressure. Pressure is defined as the force applied to the given surface of an object per unit area over which that focus is distributed. Atmospheric pressure, also known as air pressure or barometric pressure, plays a crucial role in a field of climatology. So the standard atmospheric pressure is defined as 10,132.5 Pascal equivalent to 760 mmHg. The unit of pressure is Pascal, as you already know. It is noted by letter P, is a solar quantity. It is denoted by the following formula. As you already know, pressure is equal to force over area, or mg over area, where P is pressure, F is a force, area, A is area of the surface. About calculations, example, the force of 10 N exerted on the box whose an area of 10 meters square. Find the pressure act on that box. Solution. Here pressure is equal to force over area. Therefore P pressure is equal to N Newton divided by 10 meters square, and then you get a solution. You should try it in order to know more about the pressure calculations. The second example is the force of 10 kg act on square whose area of 20 meters square. Find the pressure acting on square. Solutions. Force equal mg equal 10 kg times 90.81. This 8.181 is in accelerations, and then you get a solution about this. The practice questions on the pressure formula you should know, or you should ask yourself. Find the force acting on the body of the pressure acting is 22 Pascal and its surface area is 11 cubic centimeter. Second question is about what is the surface area of the object in the force applied is 200 Newton and the pressure at the surface is 12 Pascal. Third question is if the force of 1.5 dyne acts on the area of 0.03 cubic centimeter, find the pressure acting on that area. Second question 4 is about if the force of 90 N act on an area of 5 cubic meter, find the pressure on that area. The types of pressure, we have many types of pressure. The following are the types of pressure we get on the research. We see the absolute pressure, gauge pressure, differential pressure, silted pressure, or vacuum pressure. Absolute pressure is the measurement of pressure relative to a full vacuum, where the reference point is zero pressure. It is also the pressure of having no matter inside a space or a perfect vacuum. It is independent of environmental influence such as weather or altitude. The best example of an absolute reference pressure is a measurement of barometric pressure. The gauge pressure is the pressure measured relative to atmospheric pressure. It is positive for pressure above atmospheric pressure and negative for pressure below it. The air pressure around us increases the pressure inside any fluid that's not in a strong sealed container. These occur due to Pascal's differential pressure. Differential pressure is a difference in pressure below 2 points in a fluid system. It's often used to measure many properties such as pressure drops across filters, fluid level, or by comparing the pressure above and below the liquid, or a flow rates by measuring the change in pressure across the boundaries. Other things I can add to this is isobars. Isobar is a imaginary line connecting the area with the same pressure. You should know this.
So, thank you so much. My name is Mozakeria. I'm group member of my colleague who presented previously. For me, I'm going to tell you about types of pressure measurements. Have type, the type, the definition, and the application examples. The type 1 of pressure measurement is gauge. Gauge reference to atmospheric pressure. So the application example is car tire. The next example is water level measurement. Its example is chamber pressure. Another example is hydraulic applications. Those are examples of gauge. The next type of pressure measurement is sealed. Sealed is referenced to the sealed chamber closed with atmospheric pressure approximately 1 bar. Sealed as a type of pressure measurement, it has its application examples. The first one is it is used in aggressive media. Also, sealed is used in industrial applications. It also used in washdown environments. Another important example or application of sealed as a type of pressure measurement is used in food and beverage. Mostly, as have said that it is used in industrial applications. Both work hand in hand. The next type is absolute. The absolute is also the next type of pressure measurement. Absolute is reference in vacuum for 0 bar or non-pressure. This absolute pressure is applied in barometric, in weather stations and meteorological applications. Those meteorologists, they mostly use the absolute. Another type of pressure measurement is differential. Differential measures the difference between two pressure ports reading. It is commonly used to measure the difference between the pressure port readings. We can ask ourselves where it is applied. It is applied in filter and pump. It is applied in air conditioner. So let's on some instruments. As we have seen, these are image for how pressure is detected. Yeah, you see on your screen. The instrument, most you can ask yourself, what instrument is used to measure the pressure? We have seen many times from the primary, we already seen the instrument used to measure pressure. So now today we're going also to talk about those instruments used to measure the pressure. The first one is barometer. Barometer is an instrument used to measure the atmospheric pressure. We have seen atmospheric pressure is mostly detected or measured by the instrument which is known as barometer. Another one is manometer. Manometer is used to measure the pressure of gas. Yeah, that is the difference. The barometer measures the atmospheric pressure, while manometer used to measure the pressure of the gas. Let's proceed on difference between absolute and gauge pressure. Have seen the previously as there are types of pressure measurements. The key difference lies in what each measurement reference. Absolute pressure measures from the ideal vacuum, independent of environmental influences like weather or altitude, while gauge pressure depends on environmental influences like weather or altitude. The key difference or the key thing to consider when you are differentiating gauge pressure and absolute pressure is absolute pressure mostly doesn't depend or it is independent to environmental conditions like weather or altitude, while gauge pressure depends on those environmental influences like weather or altitude. Other difference gauge pressure is the pressure measurement relative to the atmospheric, while absolute measurement of pressure relative vacuum, how the reference point is zero pressure. Yeah, let's proceed on the next point. This slide shows us the difference between gauge pressure and absolute depending to the vacuum and atmospheric pressure. To understand the relationship between absolute pressure and gauge pressure, it is essential to recognize that absolute pressure is the total pressure in field. It is in field, which includes both gauge pressure and atmospheric pressure. The formula of absolute pressure is given as pressure in gas plus pressure in atmospheric pressure. Where the first pressure is absolute pressure, gauge pressure plus atmospheric pressure. So the absolute pressure is the sum of gauge pressure plus the pressure of atmospheric pressure. Thus is all about the absolute pressure. The absolute pressure is the combination of gauge pressure and the atmospheric pressure. Thus also is a link or a relationship between atmospheric pressure, gauge pressure, and absolute pressure. Let's continue with sealed pressure and vacuum pressure. Sealed pressure is known as positive pressure. When we say positive pressure, also you can understand sealed pressure. This pressure refers to the pressure maintained with a closed or sealed system that is greater than the pressure outside the system. This is really understandable. The sealed pressure is mostly or is maintained in a closed system. So the system that is greater than the pressure outside the inside system is greater than the outside system. In such system, the pressure is kept constant or controlled using mechanisms such as pressure regulators. Those pressure regulators are the controllers which control the pressure so as it is in normal range. The second one is vacuum pressure, also known as negative pressure. Negative pressure, it refers to the pressure below atmospheric pressure with a confined space. In a vacuum, the pressure is lower than the surrounding atmospheric pressure. You see, the sealed pressure and the vacuum pressure, they are really different. The sealed pressure is opposite to the vacuum pressure. As we see, the inside the sealed system is greater than the outside system in sealed pressure. So when we come on vacuum pressure, there is a reverse or there is opposite to the previous one. The vacuum pressure is below the atmospheric pressure within a confined space. In a vacuum, the pressure is lower than the surrounding pressure. So let's proceed to the next one. We see cyclones and anticyclones. You can ask yourselves, what are cyclones and what is anticyclones? Most you can see the image, but you can't really understand the main idea or the main message which is behind this. Let's continue, you will understand more. Cyclones, also known as low pressure systems or depressions, are regions where the atmospheric pressure at the surface is lower than the surrounding areas. The atmospheric pressure at the surface is lower than the surrounding. These systems are characterized by rising air motion and often associated with cloudy sky, precipitation, and stormy weather. Mostly in the northern hemisphere, cyclones are typically associated with counterclockwise cyclonic airflow, while in southern hemisphere rotate clockwise due to the colorize effect. Let's continue. Cyclones can range in size from small-scale disturbance like thund to large-scale weather systems such as tropical cyclones. Let's continue. So, anticyclones are also known as high-pressure system or ridges. A region where the atmospheric pressure is at the surface is higher than the surrounding areas. These systems are characterized by descending air motion, which inhibits cloud formation and leading to generally clear skies and fair weather conditions. Anticyclones are often associated with stable weather conditions including dry and sunny weather, but they can also lead to temperature.
Hello, let me continue with differences between cyclones and anticyclones. Let me start with the number one, which is saturation pattern. Saturation pattern in cyclones are characterized by inward sprawling winds rotating counterclockwise in the northern hemisphere and clockwise in the southern hemisphere, due to the Crowley's effects that have a low pressure center at the surface. Anticyclones, on the other hand, have outwards sprawling winds rotating clockwise in the northern hemisphere and counterclockwise in the southern hemisphere. They feature a higher pressure center at the surface. This shows the anticlockwise has the counterclockwise in the southern sphere, but in cyclones have the counterclockwise in the northern hemisphere. That is the opposite, which is the differences between cyclones and anticyclones with circular pattern. Let me continue with other hands in cyclones. Anticyclones generally bring stable weather conditions. They often result in clear skies, dry weather, and light winds. With the second one, which is air movement, with air movements have the differences between cyclones and cyclones. Let me start with cyclones. In cyclones, air rises at the center due to low pressure, creating a zone of coverages at the surface. This rising air cools and condenses, leading to cloud formation and precipitation. About anticyclone. Anticyclones have descending air at the center due to high pressure. This descending air suppresses cloud formation and leads to fair weather conditions. That is the other differences, which is air movement between the cyclones and anticyclones. Let me continue with the third one, which is temperature description. Temperature description. Cyclones are often associated with change in temperature. They can bring warm or cold fronts, leading to fluctuations in temperature and weather condition. With anticyclones tend to stabilize temperatures. They can result in temperature inversions where cooler air is trapped beneath where warm air, especially during calm, clear nights. About the four differences, which is called wind speed and direction. This difference, let me start with the current. Currents typically have the stronger winds concentrated near the center and often exhibit rapid changes in the wind direction as they move. With anticyclones generally have lighter winds that spread outward from the center. The wind direction is more consistent and tends to be calm. That is the differences with wind speed and direction with cyclones and anticyclones. In summary, have the differences between cyclones and anticyclones. Those differences, they are low pressure area at the center. Anticyclones, they are high pressure area at the center. Air moves upwards creating convergence with cyclones, but anticyclones air moves downward creating divergence. With cyclones spin anti-clockwise in northern hemisphere, but in anticyclones spin clockwise in the northern hemisphere. That is the first difference between which I'm saying with the first point previous. The next one is spin clockwise in the southern hemisphere, while about anticyclones spin anti-clockwise in southern hemisphere. About the next one, it is accompanied by clouds, weather, strong winds, and rains. The next one is accompanied by the clear skies of the weather and mid-breath. Let me continue with the factors that influence the pressure. There are so many factors that affects the influence the pressure. Let me start with the volume. The volume of the gas directly impacts its pressure due to the Boyle's law. When you compress a gas into the smaller volume, the gas molecules are forced closer together, increasing the frequency of their collisions with the container walls. That is how the volume will be affect the pressure. This is how when you compress a gas into the smaller volume, the gas molecules are forced closer together to increase the frequency. The next one is about the force and area. Force and area, as we have seen, pressure is mathematically expressed as P equal to F, pressure equal to force over area. If the same forces is applied, small surface areas result in higher pressure, while larger areas result in lower pressure. Pressure is defined as the force exerted particular to a surface divided by the area of the surface. The next one is about the attitude and atmospheric pressure. Atmospheric pressure decreases with increasing attitude due to decreasing weight of the air coming about you ascend to higher altitudes. There is less air pushing down about, resulting in low atmospheric pressure. About the temperature, it is also the factors which is affecting the pressure. Where the pressure increasing, the average kinetic energy or kinetic energy of the molecules according to Charles' law. As we see, the Charles' law, they are so very important to the pressure, which is the one which is motivate the temperature to influence the pressure. The higher kinetic energy means that molecules collide with the container walls more frequently and with greater force, increasing the pressure inside the container. Let me continue with the composition of the system. Different gases have the different molecular weights and properties affecting the behavior and pressure characteristics. For instance, lighter gases like helium with diffusion and pressure different compared to heavier gases like nitrogen. Gravity in field system. The gravity, it is another one which is factors that influence the pressure, including gas and liquid. Gravity plays the critical role in pressure description. Higher elevations express lower pressure to the reduced weight of the shield come above. Less gravitational force acting towards. The importance of the pressure in agriculture. There are so many importance of pressure in agriculture, irrigation system, pesticides and fertilizer application, nutrient flow into the plants. Let me start with irrigation system. Pressure is essentially for the efficient water distribution in the irrigation system. That's the first one importance in agriculture. Pressure will be motivate the crops to grow well. It helps to pumping water from the water source to the fields through the pipes or channels. This is how the importance of pressure, which is the farmers used to helping to pumping water from the water source to the field through pipes or channels. About the pesticides, the pesticide and fertilizers application. This is how anyone or any farmers can use the pesticide to protect the crops, or using the fertilizers to use the fertilizers to grow well the crops. This is the pressure is necessary in spraying pesticides and fertilizers into the crops. Sprayers use pressure to atomize the liquid into smaller droplets, ensuring even coverage of the field. Nutrients flow into the plants. Pressure regulates the flow of the nutrient solution mixed to the plant roots and ensures the roots receive adequate oxygen and nutrients, promoting healthy growth and high yields in the controlled environment. Let me continue with the fourth point of the contents about the pressure in crops or in agriculture. Seed planting and germination. Agriculture machinery like seed drilling relay ensures. This is about the seed planting and germination. With the fifth one, post-harvest handling. Pressure is employed in the post-harvest processes like packaging and storage. Controlled pressure packaging helps extend the shelf life of publishable agricultural products by reducing spoilage due to the microbial growth and physical damage during the transportation. About livestock management. In animal agriculture, pressure is involved in various aspects of system. for feed and waste management, as well as in their operations for milking machines. Proper pressure ensures efficient and hygiene process, contributing to animal welfare and productivity. That is how the importance of pressure in agriculture. The next one is about the bibliography of the diagrams. All of the phases: high pressure, we see the manometer, we see the Wikipedia contributors, the pressure, and etc. We can see these links to see those pictures or videos which I'm using in. Thank you.